Hello everyone and welcome back to the channel. In the last video we were talking about how we could add a large gear to the outside of that coin slider that could be rotated with a pulley. So we talked about that and the advantages of that, and basically that you can apply a lot more torque to this coin slider as it's rotating. The other thing that I wanted to point out is we were going to rotate that with this center gear here, but once we discovered that that was too small to actually be effective, we no longer have a need for this gear. So in the latest designs, we just eliminated that gear completely, and we're just leaving a small, I'm calling it a donut, we're leaving a donut there so that we can actually use that to center the coin slider and rotate that around the donut, but there's really no need for there to be a gear there anymore. Now, the next challenge for us is to figure out how to get a stepper motor attached to this in such a way that it will actually be able to rotate this outer gear. On this part here, there'll be a sprocket that attaches to this through a belt. I'm thinking about running a belt around here. The only problem is I didn't know exactly what size belts are available, and I just started playing around with CAD before I really got any information about that. What I wanted to test was whether I could get the tolerances of this to line up pretty well so that I could actually insert the stepper motor here and get these screw holes to line up, which they do pretty well. That took a lot of work in CAD just playing around, but try to get all that lined up. Now you can see that these screw holes here, they interfere with where the coin slider is going to rotate. And if you countersink the nuts enough here, the screws enough here, it won't be a problem. So this was just really a test piece to see if that could get that working. And I actually was able to screw that down pretty tightly. They were countersunk, so they didn't really interfere with anything. My goal was really to have the cog in this position so that the belt was actually pulling this together and closing that gap that we saw in the compliant mechanism before. But you can see as this rotates around, you're going to get closure here as this picks up a coin. And this all really does work well. But as you can tell, there's still a lot of friction there. We'll have to figure out a way to deal with that later. But the next challenge for me was really to figure out what belts are available and to figure out exactly where the center of the stepper motor needed to be in order to drive this whole mechanism. I decided to look on Amazon, and it looked like there was a few popular sizes of GT2 belt. The problem was I didn't really have any of those, and I didn't know which to order, so I ended up buying a bunch. But then a lot of those parts are coming from China, and I didn't want to wait around trying to figure out what exact belt size I needed. But then I came up with an epiphany that I could use the C equals pi d, the circumference equals pi times diameter, to figure out how to 3D print a temporary belt just so that I could get the distances right. The three sizes that are available on Amazon pretty easily are 410 millimeters, 430 millimeters, and 450 millimeters, like I have here. So what I did was just print out three belts, 6 millimeters wide, which is the exact width of the final GT2 belt. And that allowed me to kind of look at this and see how far away the actual stepper motor had to be. Now, for this 450 millimeter version, you can see that that's pretty far away. It's an okay look, but I actually want that to be closer. The goal for me is to really make this as compact as possible. You can see that this gives you a good enough distance that you can figure out where all of the parts need to be. And I think that 430 millimeters for the belt circumference is actually going to be a pretty good size. At that distance, you can move the stepper motor out a little bit further. And in this position, you can see that I've actually moved the stepper motor out quite a bit. And now that these bolt holes don't interfere at all with the cam followers. So even though they're countersunk, and it wouldn't have really been a problem, but at 430 millimeter belt size, That's going to be just about right to keep that outside of this outer gear, but also close enough so that the belt doesn't have to be too long. The other thing that I'm really proud of with these designs is like chamfering the coin sorter slot and also chamfering the coin studio slot on the backside. That narrows down the field of view so that you don't get all the intricate gear work when you're trying to take a picture of this. If you put that in and you rotate that into position, you can see that it actually shows only the penny now. And I think that's going to work out really well for the coin studio. As I talked about in the last video, these cogs are timed so that they're not trying to push down on two compliant mechanisms at max pressure at the same time to try to reduce the amount of friction that we have in this mechanism. But you can see that even though I'm using the outer gear now, it's still very sticky and hard to turn. So the thing that I came up with to fix that was to see if I could actually reduce the amount of friction by removing the cogs entirely and replacing them with bearings. So now these bearings are going to be what's responsible for pressing down on those cogs. And when we get this into position now, this rotates much more freely. So I put a little Sharpie marker mark there. You can see that I created a little bit of a gap here, and this post on the inside is really tight. So that actually allows the outside of the bearing to rotate and the inside of the bearing stays in position locked on that post. So that has been really helpful. It has created a lot less friction, and now I think this whole mechanism will turn a lot easier now with those NEMA 17 stepper motors that I purchased. So I'm pretty excited about that. The finished mechanism, when it's all put together, looks like this. And I'm pretty happy with that. You can see that we have a gear on the stepper motor now. Those are screwed into place with these and 3 bolts. And this rotates through all of its positions, and it rotates on these bearings, so that's going to work great. You can see that when we rotate through that by this first bearing here, that's going to grab the penny. It will then be taken past the camera studio on the bottom side, and then when it is rotated past the coin sorter, it will hit another bearing here and then be released. And at this point, I'm just waiting for that 430 millimeter belt to show up so that I can actually get this powered on and working the way it's supposed to. So all of that works really great. I'm excited to see how this works when I actually get the belt in, and we'll see how that works once it's powered up. So hopefully in the next video, we'll have those parts come in and we'll be able to continue working on this. There's still a part that needs to stick out at the top here that will hold on to a stack of coins and the top camera, and the bottom of this mechanism will have a lower studio and also the coin sorter. So we still have to work out all those mechanisms, but I think the most complicated pieces we've got worked out already here. So I'm pretty excited about that. So thanks for watching, everyone. That's my 2 cents. Have a great day and stay tuned for the next video. Thanks a lot, everyone.